Hello, dear students. You're welcome to Ark Institute. I'm Dr. R.K. Saini. As you know, I keep posting 10 important questions from a topic of chemistry from my channel. To continue this order, today I am posting 10 more questions from liquid solution. I think these questions help to improve your chemistry as well as to understand the basic concept of chemistry. By the way, you like and subscribe my channel, which I like very much. Okay, so now I am going to discuss 10 more questions regarding to solution, particularly liquid solution, and today I will discuss colligative properties. These questions asked in different examinations like as in JEE NEET, main as well as in advanced or NEET examination. Question first. Question number first. Calculate mass of non-volatile solute. First of all, we read question carefully, then write given information and then solve the problem. Calculate mass of non-volatile solute, molar mass 40 gram per mole, which dissolve in 114 gram of octane to reduce vapor pressure 80%. Then for solve this problem, we use relative lowering of vapor pressure. We know that P naught minus PS upon P naught equals to mole fraction of solute. Putting the value. Initial pressure P naught decrease 80%. Therefore, the pressure of solution is 0.8 P naught divided by P naught equals to XB. XB is the mole fraction of solute. And we know that mole fraction is the moles of solute given mole upon molar mass upon total moles. Total moles means moles of the solute plus moles of the solvent. Now solvent is octane. Formula of octane C8H18. Their molar mass is 114. It means the moles of octane or solvent is 1. Now I solve the problem. 0.2 P naught divided by P naught इक्वल्स टू W अपॉन वेट जो आपसे रिक्वायर्ड किया है 40, एलसीएम ले लो इसका, ये हो जाएगा आपके पास में W प्लस 40 अपॉन 40 this, then cross multiplied and check W, then cross multiply and find W. Therefore W equals to 0.2 P naught W plus 8 P naught equals to P naught plus W, or we can say 8 P naught equals to this value put in right hand side, therefore the value of change our sign and has 0.8 P naught into W. Therefore final W equals to 8 P naught divided by 0.8 P naught and hence W equals to 10 gram. Okay. Question number first. Question next. Osmotic pressure of aqueous solution of organic compound is this atm. At this temperature, find concentration. Nothing. It is also colligative property, and we know that osmotic pressure pi equals to CRT. All values are given. Given pi, osmotic pressure, R gas constant equals to value 0.0821 and the temperature is 300 Kelvin. Therefore, C equals to, putting the value 1 upon 300 Kelvin. And the answer, इसको जब आप solve करेंगे, solve this problem, then 0.0033, or we can write 0.33 into 10 to the power minus 2. Yes. Question number 2. Question next 3. Therefore, first of all, we read question carefully and then solve the problem and write all. Question next. Question third. Solution of A. Molar mass given 20 and B. molar mass this, the mole fraction of B this. Find a density given and find molarity of B. Molarity. We know that molarity of B means moles of B upon volume of solution in liter. Solution in liter. We know that sum of the mole fraction always equals to 1. The mole fraction of A and mole fraction of B always equals to 1. Therefore, the moles fraction of B given 0.6, mole fraction of A given 0.4 and their sum is 1. Therefore, the mass. It means their mole ratio. आप ऐसे भी कह सकते हो the mole ratio of B to mole ratio of A is equal to the ratio of their mass in their mole. Therefore, 0.4 B 0.6 and A 0.4 multiplied their molar mass. Mole fraction of B is 0.6 and their molar mass is 10. Therefore, 6 gram of B moles mole ratio and 0.4 into 20. Therefore, 8 gram of B. Total mass of the solution now 14 gram. And find with help of density we find volume. Given weight upon volume. Density given 0.7. Therefore, the volume of solution is 20 ml. Then putting the value. Moles of B as their mole fraction 0.6. Volume 20 into 1000 because we taken volume in liter. And as the mole fraction. And finally, the concentration of solution is 30 m. First, we calculate mole fraction of both species. And we know that mole fraction of species equals to their mole ratio. It means the mole of B is taken 0.6, then moles of A taken 0.4. And now find total mass of the solution. And we know that moles equals to weight upon molar mass. Suppose mole fraction of B is 0.6 means their moles is 0.6 and their molar mass is 10, then their amount is 6 gram. Similarly, in case of A, if their mole fraction is 0.4, their molar mass is 20, then their amount is 8 gram. And as the total weight of solution is 14 gram. With help of given density, given density of the solution, we find volume of the solution and it is 20 ml and then find molarity of the solution. Question 4. Boiling point of 2% aqueous solution of non-volatile solute A is equal to the boiling point 8% aqueous solution of non-volatile B. Equal है the relation between their molar mass. We know that boiling point of the solution A and B are equal. It means their molality is also equal. Delta TB equals to KB into M. The boiling point equal, it means elevation in boiling point of also and hence their molality equal. We find molality for solution A 2%. Their molar, it means 2 gram of A dissolved in 100 gram of solution. Therefore, the weight of solvent is 98. So, given weight upon molar mass of A upon weight of solvent in kg. Therefore, it is the molality with respect to A. Similarly, molality with respect to B, 8 gram and their molar mass is B. And the weight of solvent is 92. It means 800 gram solution contain 8 gram of B. It means the weight of solvent is 92. And then find ratio of MB to A. The ratio of MB upon MA equals to nearly 4.26. But roughly we write MB equals to 4 times. This. Question 5th. First we read question carefully, then understand symbols and then find problem. freezing point. Depression in freezing point observed of the formic acid solution concentration 0.05 ml per liter is 0.0 this. Density of formic acid given. Van't Hoff factor of formic acid. According to colligative properties of we know that depression in freezing point equals to I Kf into m. Depression in freezing point given 0.0405. I required Van't Hoff factor. Van't Hoff factor I. Kf given 1.86. And the molarity means amount moles of formic acid in 1 kg of solvent. Moles, find given weight. तो weight निकालेंगे 0.5 ml, gram per ml. It is the concentration of formic acid. And given density multiplied by given density 1.05. Therefore, it is the weight of formic acid. It is the weight of formic acid 0.5 into 1.05 and their molar mass is 46 and this mole present in 1 liter. 1 liter water means 1 kg water because the density of water is nearly 1. Therefore, your answer is nearly this. And the Van't Hoff factor I. Then now solve this Van't Hoff factor I. The molar mass of formic acid is 46. The Van't Hoff factor is nearly 1.9. Check your answer. Solve. Question number 6. Two solution A and B are prepared by dissolving 1 gram of non-volatile solute X and Y respectively in 1 kg solvent. Amount of solute equal, weight of solvent equal, and the ratio of depression in their freezing point of A to B given 1:4. Then ratio of their molar mass. And as we use depression of freezing point according to colligative properties, and we know that depression of freezing point of solution A divided by depression in freezing point of solution B equals to weight equals to m of A and m of B. Solution M contain 1 gram X. Therefore, amount of X and its molar mass is mx. Divide by 1 gram of solute X, Y and its molar mass is Y. Molar mass. This value is given 1:4. It means the ratio of their molar mass is 4:1. And the 4:1 also write this. Clear? Question 7. 0.004 m K2 potassium sulfate solution is isotonic with 0.01 m glucose. Isotonic means their osmotic pressure are equal at given temperature. The percentage dissociation of this, it means IC of glucose equals to IC of K2Cr2O7. In case of glucose, it is normal colligative property. Therefore, I is 1 and concentration given 0.01. And in case of K2SO4, first of all, we find I. Concentration given 0.004. Therefore, I of K2SO4. Is 0.01 divided by 0.004, or we can say 2.5. And then find alpha, degree of dissociation. Alpha degree of dissociation equals to I minus 1 divided by n minus 1. I 2.5 minus 1 and total number of particles furnished by 1 mole of the K2SO4. Therefore, total number of particles 3 minus 1. Therefore, 1.5 divided by 2, or we can say 0.75 or 75%. Question next. Question number 8. What weight of the glucose must be dissolved in 100 gram of water to lower the vapor pressure 0.2 mmHg. Assume dilute solution being formed and the vapor pressure of pure water given 54 point this at room temperature and molar mass this. ठीक है, और आंसर को आपको नियरेस्ट इंटीजर में मल्टीप्लाई करके लिखना 10 से. Therefore, we use relative lowering of vapor pressure. We know that P node minus PS divided by P node, and for dilute solution weight of solute upon their molar mass, weight of solvent upon their molar mass. Putting the value. Given vapor pressure of pure water means solvent is given 54.2. Lowering vapor pressure decreased by 0.4. It means the vapor pressure of solution is 54 divided by 54.2 and putting the value of given weight. What weight of the glucose? It means we required what weight of the glucose. Their molar mass is 180. We know that. In 100 gram of water. And the molar mass of water is 18. Then now find WB. 0.2 divided by 54.2 equals to weight upon 1000. And the weight equals to 200 cross multiply 0.2 into 1000 divided by 54.2. Then your answer is nearly 37. Is nearly 37. Check the answer. 33.69, nearly 3.96. In integer, we write 3.7 and multiplied by 10. Then we write 37. Occasionally, A and C are same option. Question number 9. Question 9. 80 mole % magnesium chloride is dissociated in aqueous solution. The vapor pressure of 1 molar aqueous solution of MgCl2 at 38 degree centigrade in mmHg. Nearest में देना answer and the vapor pressure of pure water given 50 mmHg. Also use relative lowering of vapor pressure. In case of abnormal colligative, we know that Van't Hoff factor I is the ratio of the experimental value of colligative properties, or we can say observed value or experimental value to the theoretical value, and the theoretical relative lowering of vapor pressure is XB. Therefore, the experimental value of P node minus PS upon P node, it is the experimental value, equals to I into XB. Now putting the value. Given P node pure water is 50 mmHg, required vapor pressure of solution, that is 50. I, first find I equals to 1 plus alpha n minus 1. Given 80 mole % dissociation, given dissociation 80 mole % means alpha is 0.8. After dissociation, Mg magnesium chloride give 3 particles. Therefore, I equals to 1 get 2.6. Putting the value of I, 2.6. And then mole fraction. Mole fraction means moles of solute upon total moles. Moles of solute. Given 1 molar solution. And the total moles. 1 molar solution means 1 mole of magnesium chloride in 1 kilogram of water. Or 1 kilogram of water means 55.5 moles of water. And now solve. 50 minus P node upon 50 equals to 2.6 divided by 56.5. Then cross multiply and find this. 50 minus P node equals to 50 into 2.6 divided by 56.5. This value is nearly 2.3 and as P node is 47.7. Therefore, we write nearly 48. Integer. Question number 10. Very important question and asked in JEE main in 2023. Question 10. Seawater contain 29.25% of NaCl, 19% MgCl2 by weight. It means if complete weight of the solution is 100 gram, then it contains 29.25 NaCl and 19 gram of MgCl2. Therefore, the weight of solvent is 100 minus 29.25 plus 19. This is the weight of solvent. And boiling point, 100% ionized. Therefore, we find elevation in boiling point equals to I Kb into m. In case of two electrolyte, we write Im NaCl plus Im MgCl2 and multiplied by Kb. First, we find I for NaCl, 100% dissociate. I is 2 for NaCl. I is 3 for MgCl2, and then find their molality. Then we find their molality. Molality of NaCl. Molality of NaCl. Its mole 29.25 डिवाइड बाय देयर मोलर मास 58.5 0.5 आ जाएगा, चेक करिए आप 0.5. एंड वेट ऑफ सॉल्वेंट 100 माइनस दिस नियरली 51 point something into divided by 1000. Therefore, the molality of NaCl. Similarly, molality of MgCl2. Their weight 19 gram. Their molar mass is 95. It means their mole is 0.2. Divide by mass of solvent. This is the mass of solvent into 1000. And now solve the problem. Therefore, the answer of question 10 is 116 degree centigrade, because the elevation in boiling point is 16 degree centigrade. Check, please check. NaCl I into M NaCl and Im MgCl2 M, and their I is 3, and then multiplied by Kb given 0.52. Therefore, the delta TV is 16. Therefore, the boiling point is 100 plus 16, and hence 116 degree centigrade according to requirement of the question. Okay, thank you. These are the questions of solution, and in another class we also posting 10 questions. Thank you.